Jai Hind students, welcome to my YouTube channel. Students, in this particular lecture, we'll discuss about the magnetic field lines and its properties. Actually, the magnetic field line is the path along which an isolated north pole will tend to move if it is free to do so. Now, since an isolated magnetic pole does not exist, thus a small magnetic needle is used to plot the field lines of a magnetic field.
So, magnetic field lines. Let's discuss this topic. Magnetic field lines. So, first point to be noted is that it is a hypothetical concept. Hypothetical means imaginary concept. It does not exist in real. So you must be asking to yourself, what's the purpose of developing this concept? So the answer lies in the fact that the concept of magnetic field lines has been developed so as to visualize the strength of magnetic field in a given region. In a given region, in which part of the region the magnetic field is stronger, in which part of the region the magnetic field is weaker, so that we can visualize by drawing the magnetic field lines with the help of magnetic compass needle and a bar magnet, right? So basically magnetic field lines, this concept has been developed. The concept has been developed so as to visualize the strength of the magnetic field in a region. The strength of magnetic field in a region. So that is why this concept of magnetic field lines is developed, right? Now let us discuss some of its properties. In the video, students, you must have watched the magnetic field lines, how the magnetic field lines can be visualized, isn't it? So I will draw that diagram. Suppose this is the bar magnet. Again, I must remind you of the fact that magnetic poles always exist in equal and opposite pairs. So if this is a magnet, it must have two equal and opposite poles. One is the north pole, the other one is the south pole. North, south, they have got some pole strength. Both are of equal magnitude but different nature, isn't it? And these poles are not exactly the endpoints, but near the endpoints of the magnet, where the magnetic force of attraction is maximum. So it is somewhere in this region, near the endpoints. So suppose this is the north pole, and let us consider this to be the south pole. Right? So if you want to plot the magnetic field lines, then students always remember the magnetic field lines are always in the form of continuous closed loops. They are in the form of continuous closed loops. They neither have any starting, that is emanating or initiating point, nor do they have any terminating or end point. So I will write the properties as well, right? So first property is magnetic field lines are in the form of continuous closed loops. They are in the form of continuous closed loops. So this is it. Inside the body of the magnet, the field lines are directed from south to north, like this. The field lines are directed from south to north. While outside the body of the magnet, students, the field lines are directed from north to south, like this. It is directed from north to south. You need to indicate this arrow. So this becomes a closed loop. So this is what I am talking about. Magnetic field lines are in the form of continuous closed loops. And you need to remember the direction. Inside the body of the magnet, the field lines are directed from south to north. And outside the body of the magnet, the field lines are directed from north to south. So you can complete this diagram. It should be like this. Let me draw a few magnetic field lines for you. So inside it is from south to north, and outside it will be from north to south. I'm not completing it, but it's the fact that it is in the form of continuous closed loops. It's like this. So inside the body of the magnet, the field lines are directed from south to north. They are directed from south to north, while outside it is directed from north to south. So diagram should be like this. Try to draw symmetrical diagram. Okay, these are the magnetic field lines. You can continue over here as well, right? You can complete it. So this will give you a visual representation of the magnetic field line. So that's the first property. Magnetic field lines are always in the form of continuous closed loops. It is in the form of continuous closed loops. So they neither have any starting point nor do they have any terminating or end point. Second, inside the body of the magnet, the field lines are directed from as I told you, from south to north, while outside the body of the magnet it is directed from north to south. It is only then it will be in the form of closed loop. Clear, students? Third, these are some of the properties of field lines. Now, what will be the direction of the magnetic field at a point? Now look, it's a curve, isn't it? It's a curve. So if you want to find out the direction of the magnetic field, say at this point, then what we'll do is, the field line is along this direction. So at this point we'll draw a tangent. So it will be like this. So this will be the direction of the magnetic field at point A. So suppose magnetic field is represented by capital letter B. This is B. B stands for magnetic field. This is magnetic field, suppose. So the magnetic field at a point is given by drawing a tangent at that particular point. Clear? Suppose you want to find out the direction of the magnetic field at this point, say at point C. Then the magnetic field lines at point C is along this direction, like this. So at point C, you will draw a tangent. Tangent is like this. This will be the direction of the magnetic field. Clear? At this point, students, the direction of the magnetic field, again, it is like this. So at this point, you will draw a tangent like this. So third, very important property is, the direction of the magnetic field at a point is given by drawing a tangent at that particular point, right? So the direction of magnetic field is given by drawing a tangent at that particular point. So this was regarding the direction of the magnetic field in the region of the bar magnet, right? Fourth property. Now look, students, as I've told you, the concept of magnetic field lines has been developed so as to visualize the strength of the magnetic field in a given region. So here it's pretty clear. These are the regions where the magnetic field lines are crowded. They are closer towards each other. So here the magnetic field strength is stronger. While in this region, the magnetic field lines, they are less crowded. So there the magnetic field strength is weaker, right? So basically the relative closeness of the field lines, the relative closeness of the magnetic field lines gives a measure of the strength of the magnetic field. So, the relative closeness of field lines gives an estimate of strength of magnetic field. Clear, students? So I must again repeat, in the region of magnetic field, the portion at which the field lines are crowded, there the magnetic field must be stronger. While on the other hand, in the region where the magnetic field lines are less crowded, there the magnetic field strength must be weaker. So basically, the relative closeness of the field lines that gives an estimate of the strength of the magnetic field in that particular region. And students, another very important property is no two magnetic field lines can ever intersect with each other. What I mean to say is that magnetic field lines can never intersect each other. Can you think of the reason why the magnetic field lines cannot intersect each other? It is because, students, the direction of the magnetic field at a point is unique due to a source. The strength of the magnetic field as well as the direction of the magnetic field at a point must be unique. Unique means a single particular direction, right? So at any given point, magnetic field should have a single particular direction. And also, in this point we have discussed, the direction of the magnetic field at a point is given by drawing a tangent at that particular point. So, why two magnetic field lines can never intersect each other? I will elaborate this with the help of a diagram. Let us consider this particular diagram, students. Okay. This is one of the magnetic field line. Suppose this is the first magnetic field line. Correct? Let's consider two magnetic field lines are intersecting at a particular point. Let's see what happens then. So this is the first magnetic field line, and suppose this is the second magnetic field line. This is the second magnetic field line, and this is the point of intersection. Suppose O is the point of intersection. Again I repeat, students. Let us consider the two magnetic field lines intersect at point O. Now at point O, if you consider the first field line, then the direction of the magnetic field at point O due to the first field line will be given by drawing a tangent at this particular point. This is suppose the magnetic field B1 at point O due to first magnetic field line, right? Now at the same point O, the direction of the magnetic field due to the magnetic field line second would be given by drawing a tangent to the second field line. It is B2. Now look, students, what is happening is at the same point O, we have got two different directions of magnetic field, which obviously is not feasible, which obviously is not possible. This is the reason why magnetic field lines can never intersect each other. I repeat, students, the direction of the magnetic field at a point must be unique, must be particular, must be in a single direction, isn't it? Here what is happening is, if we assume the field lines to be intersecting with each other, then at the point of intersection, we are getting two different directions of magnetic field. Whereas at point O, there should be only a particular direction of magnetic field. But here, due to the intersection of magnetic field lines, we are getting two different directions of magnetic field, which is obviously not possible. So this is the reason why magnetic field lines can never intersect each other. So students, these were some of the properties of magnetic field lines, right? So I hope you have enjoyed thoroughly this particular session. And this was just an intro regarding the magnets, the properties of magnet and field lines and its properties. So that's it for this particular session. Do join me in my next lecture then. Till then, do take very good care of yourself. Always be happy. Thank you.